so that's on, if you go on package.
Oh, yeah. Oh, it's smaller right now.
Well, it's in inches.
5.25 and the thing is...
5.45, I think that.
Oh, okay, 4.5 and 3. And then, yeah, that makes more sense. Then the lead, we said the height would be that, which is not described here. It's not described in here. It's like halfway, right?
The height, yeah, it's about halfway, so I'd say 1.4. It's not going to affect results too much.
1.4. The width, that should be B.
Yeah, B. Yeah.
0.8. The thickness, that would be H.
Yeah, 0.15. Yeah.
0.15. That's fine. And lead foot length. Okay. It's inwards. So I guess it's A1.
Yeah, 1.33.
How do I tell it that it should be inwards, not outwards? Should I put minus?
No, it will work if you've got a lead shoulder.
Shoulder.
So if you make that really, really thin, 0.05 is, yeah. And then if you make if you do the 3D model, the 3D model in the cube, you can just see what your things are doing.
Oh!
So something's wrong.
Yeah.
So for the package thickness, we need to put 2.8.
Yeah, 2.
No, that's the lead thickness. The lead thickness is right. That's what we need to put the, yeah.
Oh, that's 1.9, 0.15.
1.4, I think we had.
Oh, 1.4?
Oh, sorry, yeah, that's right. Yeah, 0.15 is right. Yeah, that's 2.8, wasn't it?
Okay.
I think the height was 2.8, wasn't it?
Oh, 2.8.
I think in the data sheet at least. If you just
yeah, I always go with 2 for some stupid reason. Yeah, T.
2.8, yeah.
2.8. Yeah,
that should be pretty good. The only thing we need to change now is the material. If you put that to ferrite, because all inductors are pretty much made out of ferrite. Well, in short terms at least.
This is oh yeah, it's an inductor. So.
Yeah.
Can I say that?
Yeah, that's actually, let's just check the die. Sorry. But at least it's in the right it's the right size now at least. Go package type. Okay, we can ignore that, but go on to solder. But yeah, if you change the program model to deleted.
Oh, okay. It doesn't do it automatically?
No. And then package. No, actually ID is somewhere else. If you go on ID, so we're package. We just need to type in the package type. If you might mess it up actually. We need to pick a C lead.
C lead. Here.
Yeah, that's maybe if I can just request control and just type in something. Yeah, if I go here.
Oh, you want to change the bucket name.
Hopefully. Nah, because it's got a die here, but we don't want a die because we don't have dies, but that will mess up the exported material property.
Oh, okay.
So if we go bend, yeah, see how it's grayed out die.
Okay, okay.
So when we export, what Sherlock does is it averages a material property for a package, but what it will do here is just apply pure ferrites.
Okay.
If we had a die, it would kind of average out the area of the die length, width, and thickness, and then average the volume of the rest of the package, and then combine them into one material property because it's just making one.
When do we want dies and when do we not want dies?
So we don't want dies on these inductor types or capacitors or is this a diode? I think that's a diode, yeah.
Yeah.
But we do want it in QFNs here, so.
Oh, okay, the QFNs are the ones that need dies. Okay.
Yeah, and also the BGAs as well. So.
Okay, understood.
Yeah, so for this we'll need to use a Devermont QFN.
For the okay, we need to check the materials then.
Yeah.
Is there a general rule, like all QFNs should be over mold QFNs, or are some QFNs not over molded?
So I think what you've got here as well, it's all over molded, but we've got different CTE values here that we can choose from. So if we know through OROS, if we check in OROS and find what the CTE of the mold compound is, you can enter in here.
Okay, okay, and that comes from ours. For all of the ICs, we should check in OROS?
Yeah.
For all capacitors, resistors, inductors, and diodes, no die?
No die, yeah.
And most of them, well, diodes have LEDs, whatever.
Yep.
Their legs. Capacitors, only electrolytic capacitors have legs.
You can have tantalum capacitors as well, which if I go, I think chems. Yeah, those are capacitors still, but they're leady tantalum capacitors.
Okay.
But so Sherlock should get most of the passives, and if it doesn't get an inductor, and if it's only a couple, then we can manually edit them ourselves. But let's say if you go on to you go into your part list and everything's kind of not picked up by the part database, and you really want to send it to ANSYS because we don't want to be entering loads of packages. Fortunately for this, it's got most of them, so we can do fix it in the case where it's not got them.
Okay.
But the one thing that you'll still need to do is enable the lead modeling to get the orientation right. Fortunately for us, it's not too many.
Yeah.
You'll get pretty quick at it, but for the big BGAs, it's a bit more important as well.
To change the.
Yeah. It's been picked up by the part database from ANSYS, but they don't know the actual material properties because the customer doesn't publish them. We have to ask them, and then we enter the information or us basically.
Yeah.
And then same for the die dimensions. I mean, they're not too far off, but for instance, I know that this Oryx device has a 0.2 millimeter die.
Okay.
But you can find all that information on OROS.
In OROS, yeah. That's one thing I need to do.
But yeah, and then the other thing we need to do here is enable ball modeling. And then
I have a question. Why do we need to do the ball modeling if we do a script to do the walls in mechanical?
Yeah, so when we're doing fatigue analysis, that kind of scripting makes very detailed solid joints, but it makes the model a lot more complex. So to consider the effect of other components on the component that we're modeling in detail, it's good to have I'll show you, kind of just some very basic, there we go.
Yeah, because those little squares will get replaced by like real balls, right? With different types of material.
Yeah, the copper and the solder. Yeah, so that's when we're doing really in detailed analysis, but for the first step in the analysis is the kind of the strain map with the components. We don't model in that much detail.
Oh, okay.
Because you can imagine, if I save this, it should look good.
Oh, before we proceed, Carla, Dinesh, do you guys have questions until now, or are you following?
I'm okay.
No, I'm fine.
Okay.
Yeah, I'm doing the same changes that you are doing.
Good. Yeah, so for the BGAs, it's important to model these because what you got to remember is if we show all the BGAs, these BGAs will impact this BGA, they'll all combine together to impact each other. So we need our kind of model of the component to try and consider its effect when we're predicting fatigue on, say, this one. But yeah, in terms of, so there's still quite a bit of clearing up and checking all of us and getting the QFNs in, but we can make a model to begin with, and you can view. Yeah,
so as a summary, to focus, what we need to get from ORAS, I will write this down. We need to get from ORAS the package size.
Yep.
We need to get the die stuff.
Yep.
What else is important to get from ORAS?
So for a BJ, the substrate material.
Okay, for BGA substrate.
And then for QFNs and BGAs, the overmold material properties.
Okay.
Because these are just generic at the moment. We do get, some quite a bit of variation.
Okay.
The main.
Okay. Those materials will be guessed by the thing, but probably not correct.
Yeah, these are guessed from Sherlock, but Sherlock's only got like a generic BGA material property for everything.
And this does not get updated when we update the. If we update the database with what changes we did, it doesn't get updated in the database.
Yeah, it does actually. How was it that you do that?
But we only have to do that once.
Yeah, you only have to do that once, and we'll get the. It was. I think it might be.
Stuart, I have a question. If there is or if it exists like any kind of documentation about everything we are seeing about the components, or not yet? If there's nothing documented about it, or that we can take a look probably as a reference, or it doesn't exist?
I'm in the process of writing it up. So there's no document yet, but I'm making one.
So you learned by being very frustrated.
Yeah, I've gone through all of this and made my process good enough, teaching other people. You'll find actually so this will be a good demonstration actually. So it's one of these buttons, but I can't read actually what, because my face goes over them. But it's
one
of these, yeah.
Add new parts to the list.
I think it's.
The one is update from part library from part list.
So you can update part library from part list. So anything that we changed here will get read back into the part library.
Okay, okay.
Um,
And so whenever we do an update, should we export that and upload it into the Teams, or?
Yeah, that would be good. Yeah, yeah. If everyone starts to work on new projects and we'll edit parts, and as long as they're done correctly, we can have a good database to cut down some of this work that we're doing now.
Okay, okay. This would be amazing. We're your little team from North America.
But yeah, so that's what we need to do for that. And then let's say that we've got all of this. I'll stop control now. Let's say we've got all of these entered in properly. If you go into the analysis on the left, and then just go into any FEA study. So yeah, that's fine. Export FEA model. And then put it somewhere that would be good. Yeah, and make sure for Dinesh and Carla that you've got the file type ANSYS Workbench journal.
It should be always a version, right?
Yeah, the Workbench journal. It's in the Workbench journal. And then PCB modeling, that's fine. So the options we've got here is we're not exporting a mesh, so it doesn't actually matter about the top one, but the PCB model, you can export layered information, but we just export the PCB as one block because we materially measure the PCB not by the material.
Layers? I don't think we did the backup.
Yeah, no. No, because we're going to override the material property with the measured material property.
Because you measure the CT.
Yeah.
Right?
Yeah, because it's all. Well, you can never really get it good with Sherlock, so it's always seemingly wrong.
Okay. So even the material?
Yeah.
So we didn't change anything at this point on the stack up.
Yeah, you can do to get like a feeling of what this PCB-CT would be, but you never get anything accurate really. So.
Okay.
Yeah, so that's all fine for that. And then if you go just through these options, if you go to trace modeling, if we'd enabled the layers, you can actually get it to export the copper traces.
Oh yeah.
But we're not doing that either. The mount points don't need to be enabled. It's the drill holes in there, we don't need them. So if we put that minimum size to 3, because that's what we've been doing in that,
That's the model.
And then that's all fine. So if we go to lead modeling, enable this so we can see our leads that we've made.
Which order should we?
It doesn't actually export a mesh, so it doesn't really matter.
Oh, okay, understood.
We're just getting the geometry.
So these 3 don't matter, right?
Doesn't matter, yeah.
Okay.
We don't want wire bonds. We don't want heat sink, spotting, or mechanical parts. That's all fine. So yeah, we can export now.
So it will create a new one, right? It will not import into my current.
But I'll show you how to get it into your current one.
Amazing, because that was one of my biggest questions. I was like, how do I get it back?
And I expect you'll probably get some errors when you do this because we've not printed in all the parts properly. But it will be a good kind of point to show what you might see.
Okay.
If you've not done something right.
So the way that you work is usually creating another project, a blank project for the Sherlock thing, and then
Yes, there's a few ways that's one way. What I typically do is I bring in the step file into my existing system model, and then run the Python script that Sherlock exports to map the material properties.
Oh, okay. It's
so,
okay.
Yeah.
Takes too much time. Mine is thinking.
Dear.
Is yours going okay, Dinesh?
Yeah, I'm still at A.
And it was just
Yeah. Hey, don't mock my machine, okay?
That's us to pay for another one.
We already have a new machine.
Yeah. You should be able to click on that. But you can see it looks a lot better now. So you've got some overlapping components. Yeah. But
I guess it's population thing, right?
yeah, the populated an area.
In my case, Stuart, was a message that something isn't on the material. So when I go inside the engineering data, I saw 2 points with negative in modular. So I just changed it, right? And that's all. I have to do it, right? It will work, I guess.
Yeah, so
why?
that means that, so Sherlock does something bizarre in those situations.
Okay.
And it's normally when you've got like a QFN. If you go back into Sherlock, Alejandro, if you go onto a QFN, so let's say IC507.
This one?
507.
500.
It was just one
This
line.
one?
Yeah, that's it. Yeah, if you go edit properties, typically get negative Young's moduluses if you've got the flag dimensions or the pad dimensions wrong.
Oh.
Okay. So how do I know, Stuart? I thought that only I just like eliminate the minus and that will work, or no? How do I know the correct Jones modulus, or just leave it like that? Eliminate the minus?
Yeah, let me send you a message about, I've got an email because I had this problem and I spoke to Ansys to understand what it was doing. So I'll send you an email.
Okay.
For it. The best way is to fix the Sherlock component and export again.
Okay, that's fine. I will do that in Dinesh, for you it works okay, yes? Alejandro?
Yeah, for me, okay, works now. Yes.
Yeah, okay.
I have the model open.
Okay, I will fix it then. You can continue, Stuart.
Yeah, okay. If you could, I've only got a minute now, but if you go onto the workbench again.
Workbench.
Yeah, so what Sherlock's done is it's got engineering data, which is the figure in A1 or A2.
Yeah. So we export that and import it in our project?
Yeah, that's right.
Okay.
Sorry guys, I didn't realize I have another meeting, so I have to go.
Yeah.
I think
Thank you,
Stuart.
Yeah, I'm gonna go as well.
We will have on Friday.
Yeah, okay,
Yeah,
we meet on Friday. Thank you.
Yeah,
Have a good one, guys. Thank you so much, Stuart.
Okay, bye.